Okay, the first thing we're going to do is we're going to just review scientific notation that we've talked about already. And so I'm looking here at just the general form of a number in scientific notation. Of course, the first number here, we've called it the base value or maybe the original number. It has to be greater than or equal to 1, but less than or equal less than 10. And then it's always multiplied by 10 with the exponent. That exponent describes how many places the decimal moved, as we've talked about. So it's important to remember if it's positive or negative as well, that means something with regards to how the decimal will move or has moved. So that's the general form of the number in scientific notation. And I just wanted to look at this number here that does mean something significant. We're going to talk about the hydrogen atom. This is the smallest atom, I believe, in the periodic table of elements. And its weight is described to be 1.67 times 10 to the power of negative 24 grams. Okay, so not 1 gram, but much less of a gram as a matter of fact. Our goal here will be to write this number in standard notation. Okay, so we're going from this value that's in scientific notation, and we want to write it in standard notation just to appreciate what that looks like written as a normal number. So we're going to write down 1.67, okay, and as you see, I've already done my best here with this device to move the decimal that was right here and move it to the left 24 times. And I moved it to the left because the exponent here on the number in scientific notation is a negative, and so I need to move the decimal to the left 24 times, and it ends up way down here. And of course, in all of these spots that I've just created, you're going to put zeros. So this number in standard notation is going to say this. It'll be represented like this. And of course, this is a very small part of a gram, immeasurable pretty much, unless you have high-tech equipment. And that's how much one hydrogen atom that makes up, of course, water and so many other things. That makes up about that much of a gram. Just to put this in perspective, a paper clip weighs 1 gram. So think about how much less a hydrogen atom weighs then. Pretty cool. All right. So that's a very, very small number. And of course, numbers in scientific notation are used to represent values that are very, very big, or in this case, very, very small.